Welcome back, students. So last time we have discussed applications of the matrices and many types of matrices which are already available in the MATLAB package. Today we are going to discuss many matrix operations which we can perform on the available matrices. So the first and the foremost application here is the addition. So there are basically two types of additions. One is the addition of the two or more than two matrices, while the other one is the matrix addition with a scalar number. So first of all, let me have a matrix that is A. So that is, let me call a matrix, and that is a 3 cross 3 matrix, and let me have a 2 4 6 semicolon 3 6 9 semicolon, and then 4 6 and 8. That is a 3 cross 3 matrix. Okay, so in order to add a number with it, let me have a number that is let me have it n, and n is equal to, let me call it 6. Okay, so what if I want to add a plus n? What it will do? Okay, you can clearly see that the dimensionality of the matrix A is 3 cross 3, while this number is of 1 by 1. So how would it do? Basically, that is a very important and very useful functionality of the MATLAB, that it will first vectorize the number 6 and then add it with all the elements of the matrix A. So how would it perform? It will basically do it like this one. Okay, so that is, you can see that 6 is added with each of the numbers here. Initially, as we can see that the dimension of it was lower than that of the matrix, but what it has done, it has initially picked that number, multiplied that with the ones matrix, and then added them together in such a way that the size of the two matrices was equivalent. Okay, so that is the operation for the vector addition. Okay, so any number can be added with any size of the matrix or any size of the vector. So suppose I have a vector here like 2 4 6. Okay, so that is a vector. What if I want to add a plus v? What it will do? You will see that it cannot add them together, because the size of the vector v is 1 cross 3, while the size of my original matrix A is 3 cross 3. This functionality is only applicable for the vector addition. Okay, similarly, what if I want to add the two matrices of the same size? So suppose I have another matrix B, and let me have that matrix equal to 1 2 3 semicolon 4 5 6 semicolon 7 8 9. So that is another matrix B. So in order to add two matrices, it is mandatory that two of the matrices should have the same dimension. Okay, so as the dimension or the size of the matrix A is 3 cross 3, similarly the size of the matrix B is also 3 cross 3. So I can add them together very easily like this one. Okay, so that is A plus B. We can add them together very easily. So that is the usability of this operation. Similarly, what if I want to add another matrix with it? How can I do it? I haven't stored the values of this A plus B into any other variable, so that's why those values are now by default stored inside this ANS variable. So by writing this ANS here, what I will do, it will get this one. So what is basically the drawback of storing any values in the ANS variable? That is basically, once another operation is performed and that the result of that operation is not stored anywhere, that will be stored in the ANS, which will be replaced with the previous values. Okay, so now you can see that the value of ANS is like this one. Once if I have A equal to, let me have A multiplied by 2, so that is now this one. So you will see that initially ANS was this, but once now you will print it, you will see that it will store the values which were recently stored in it. Okay, so that is the ANS operation. Similarly, in order to multiply two matrices, what is basically the condition? So in order to multiply two matrices, it is mandatory that the columns of the first matrix are equivalent to the rows of the second matrix. If it is not like this, it won't give you the product of those matrices. So suppose if you have A which has 3 columns and B which has 3 rows, so their multiplication is also possible, and you will see that their multiplication is this one. Okay. Similarly, if you have another matrix like C, and that C is 2, 4, 6, that is a vector. Similarly, D is equal to the 4 semicolon 6 semicolon 8. So now it has 3 rows and 1 column. So you will see here that this is like a column matrix. So multiplying C by D, what it will do, it will give me the value, because the number of columns in C are 1, 2, 3, while the number of rows in D are 1, 2, 3. So as the number of columns of the first matrix is equal to the number of rows in the second matrix, so this multiplication is possible. Similarly, what if I want to multiply D with C? What will happen? It will give you this value. Multiplication of any matrix with a scalar. So let me have A and multiplying it with the number n, which I have previously stored as 6. So what it will do, again it will perform the same operation, that n will be multiplied with each and every term of my matrix A. Okay, so n was basically equal to 6. So when it was multiplied with 2, I have got 12. Similarly, when it was multiplied by 4, I have got 26, and then so on. Okay, you can see that the values are basically the multiplication or product of the n with each and every value of the matrix A. Okay, so there is also another very important operator in MATLAB, and that is the dot operator. So what is basically the dot operator? So suppose if you want to multiply A and B together, what will happen? That is A, and now this is B. How would these two be multiplied together? The first row of this matrix will be multiplied with the first column, then this first row second column, then first row third column, and will be added together like the matrix operation which you have seen in your linear algebra class. Okay, so that is the conventional multiplication operations of the matrices. So suppose if you want to multiply them together in such a way that the first element of the first matrix is multiplied with the first element of the second matrix. Similarly, the second element of the first will be multiplied with the second element of the second matrix, and so on. So that is basically the dot multiplication. So let me write the A dot B, and you will see that it is now has occurred, because 2 multiplied by 1 is 2, 4 2 is 8, 6 3 is 18, 3 4 12, 6 5 30, and the last one here 8 9 72. So that is the dot multiplication here, and this thing is very handy for you to understand and to take a look at, and it will be very helpful for you to deploy it in your different tasks. Similarly, as we have discussed that there is the operation here, and that is the size. So what is size? Basically, size gives you size of the matrix. Similarly, if you want to find the length of a matrix, what it will give you? It will give you the number of columns in that matrix, and that is 3. There is also another operation, and that is the sum operation. What is the sum operation? So let me have the row matrix here, and that is X. What if you want to find the sum of these 3 elements? How would you find it? So you will just write the sum here, and after writing sum here, inside the brackets you will write X, and running it you will get their sum. Okay, so that is a very handy operation. Similarly, if you have a Y, so Y is this column matrix, and again writing sum here, it will give you the same value here. But what if I want to find the sum of this matrix? How would I find it out? So writing sum A here, what it will give me? It will give me the values or the summation of the values which are basically in the column here. Okay, so that would be very difficult for me to find the summation of all the elements which are available in the matrix. So how would I do it? So first of all, let me store it in the matrix or in the variable that is called temp. So writing sum here, and after it let me have sm, and for sm I will again sum this temp here, and it will give me the summation of all the entries which are available in my matrix A. So you can also see that 2 plus 4 6, 6 6 12, 12 3 15, 15 6 21, then 30, then 30 and 34, 40, 48. So that is the 48, which is the summation of all the values which are here. Okay, so that is about the operations which you can perform over the matrix here. Okay, similarly, what if I want to find out the determinant of my matrix A, or let me have another matrix here of 2 cross 2 size, and that is, let me have D equal to 1 comma 4 and 5 comma 2. Okay, let me have this matrix, and in order to find the determinant, what I will do, I will just write det here, and writing it I will get the determinant here. So that det will give you the determinant of a matrix. Similarly, what if you want to calculate the inverse of a matrix? So again, writing inverse of d, inv is the used for the inverse. So writing it will give me the inverse of a matrix. So again, that is the inverse of a matrix. So multiplying d with the inverse of it, what it will give me? It will give me the identity matrix. So it basically shows me that this matrix is the inverse of my original matrix D. Okay, similarly, transpose, we have seen that how to find out the transpose of a matrix. So if I have a matrix D, so in order to find the transpose of it, what I will have to do, I have to put the inverted comma, or this inverted comma is also called the apostrophe. So writing it here, I will get the transpose of my matrix here, in which the rows will be converted into the columns and vice versa. Okay, so that is about the transpose operation of a matrix. So I think it's enough for today, in which we have covered the multiplication, addition, determinant, inverse, sum of the columns, and so on. So I will see you with some more examples, with some more problems in our upcoming video. Thank you so much, and I will see you soon.